Hey there, welcome back to another video from the Math Doc. We're continuing on our journey with equations, and we will be starting to work on solving two-step equations in this video. Take a look at the previous videos. If you are new to this channel, please subscribe, and let's get going. So before getting into two-step equations, let's just review properties of equalities. We looked at these in the previous video, which will be linked below in the descriptions, but we are talking about the addition property that you may remember, where if A equals B, so if we have an equality of A equals B, then we can also say that A plus C equals B plus C. So we can add the same number or the same variable to both sides of the equation, okay? And we will be able to hold the equality, so it'll continue to hold true. The same thing goes for subtraction. If A equals B, then A minus C equals B minus C. So here we've subtracted the same number or the same variable or combination of them from both sides of the equality. And by doing the same operation on both sides of the equality will continue to hold true. We have the multiplication property here, and I use the dot symbol for the multiplication. As a reminder, the dot is just like the x, but we use the dot when we go into equations because when we have a variable, the variable is usually x. And so we don't want the multiplication symbol to get mixed up with our variable, so we use the dot. So if we have A equals B, then we can multiply both sides of the equality by the same number or the same variable. So A times C equals B times C. So by multiplying both sides by the same number, we preserve the equality. If A equals B, then A divided by C equals B divided by C. That is our division property. Again, just like the multiplication and the others properties, as long as we do the exact same operation on both sides of the equality, it continues to hold true. Why do we need these properties? Well, our goal is to isolate our variable, right? We want to isolate variable x because we want to solve for it. When we have an equation with a variable, the end result is that we do want to know what the variable is equal to. And in order to do that, we have to isolate it, okay, on one side of the equality or the equation. So that is a quick reminder of the properties, and we will be using these properties over and over again in all the examples, so they will become second nature to you. So don't worry if you're still a little bit confused about them. The main thing to remember is whatever you do, whatever operation you do on one side of the equation, you have to do it on the other, and you have to do it on the entire equation. And we will look at examples that will demonstrate this. Now, when we do these operations, usually what we're actually going to be doing is we're going to be looking for an inverse operation to whatever it is that is inside the equality. So let me give an example. For instance, if we have the equation x plus 3 equals 5. Now, we would like to isolate our variable x here. But in order to do that, we have to somehow get rid of this 3, right? We have to do something about that. We have plus 3 here. What is the inverse operation to addition? The inverse operation is subtraction, right? So if we see that we have plus 3, that is a tip that what we should be doing now is subtracting. So if we subtract 3 from both sides of this equality, what happens? We have x plus 3 minus 3 equals 5 minus 3. Okay, now what can we do with this? Well, 3 minus 3 is just 0. So we remain on the left-hand side here with just x, because x plus 3 minus 3 is x plus 0, and we don't have to even write the 0. 5 minus 3 is 2, right? So we got the result x equals 2, and if we want to, we can check this result by substituting x equals 2 into our original equation to make sure that it is correct. So that was the inverse operation to the plus, right? What if we have an example with a subtraction problem? For instance, x minus 7 equals 2. Okay, here we're looking at the inverse operation to our subtraction, and that is just addition, right? So now let's add 7 to both sides of the equality. Again, we always have to use the same operation on both sides of the equation. So we have x minus 7 plus 7 equals 2 plus 7. Again, our negative 7 and positive 7 here will cancel. They'll give us 0, and we have x equals 9. And again, we can check our result by substituting inside our original equation. What about multiplication and division? We know that multiplication is the inverse operation to division. So let's look at an example with those operations. Let's look first at 2 times x equals 14. And again, I used the dot symbol for multiplication. So we want to isolate our variable x, but we have this coefficient 2. What can we do? Well, it's multiplying, so therefore the inverse operation is division. Let's divide both sides of this equation by 2. When we do that, we get 2 times x divided by 2 equals 14 divided by 2. Now, remember, we have a rule that is called the commutative rule, and you might not remember what that one means, but basically when we have the same type of operation, we can switch the order, right? So what I can do is I can write 2, and instead of writing times x, I can write divide by 2 times x. So I switched the order here, and I did that so it would become clear that 2 divided by 2 is done separately and just equals 1. So that equals 14 divided by 2, which we know is 7, right? Now we have the 2 divided by 2. 2 divided by 2 is just 1, and 1 times x is x. So we get x equals 7. Again, we can substitute into our original equation and make sure that we got that right. Now, we can look also at an example with division, initially with an equation with division. So we have here x divided by 3 equals 2, for instance. And I want to do that in parallel with writing this equation slightly differently, but with the exact same meaning. So you have to recall that when you divide something by a number, it is similar to multiplying that thing by a fraction of the same denominator. So x divided by 3 is exactly the same as writing x thirds, okay? You can also use the language x over 3 or the fraction x over 3, but either way, these two things are equal. X divided by 3 is equal to x over 3 or x thirds, or we can write it as x times 1/3. All these are equivalent. Okay, so we can do these in parallel. So our operation here in the equation is division. The inverse of division is multiplication. So how about we multiply both sides of this equality by 3. When we do that, we have x divided by 3 times 3 equals 2 times 3. Okay, so on the right-hand side, we obviously have 6. What happens on the left-hand side? Well, divide by 3 and then multiply by 3. That is basically just 1, right? If we divide something by 3 but then multiply it by 3, we haven't done anything. So again, here we have x equals 6. On the other hand, we can do the exact same thing right here on the right. Let's multiply both sides of this equality by 3, and we get x over 3 times 3 equals 2 times 3. Again, on the right we have 6, but now it's so clear to see how the 3 on top and 3 on the bottom of the fraction cancel each other, right? We can do that, and we get x equals 6. So in both ways, we saw the same behavior. So now that we kind of reviewed the type of operations we would have to do, since we're talking about two-step solutions, two-step equations, it's important to figure out which are the first step we take. So basically what we're going to do from now on is just look at some examples, one after the other, and slowly get used to these ideas. So let's look at this example here. 5x plus 2 equals 17. Okay, now in this example here, in order to isolate x, we see that there are a couple of things we have to do. We have this 2 here that is in our way, right, from isolation, and we also have this 5. Now the reverse operation for the 5 would be dividing by 5, right, because we have 5 times x here. The reverse operation for the 2 would be subtracting it, because we have plus 2 here, right? The question is, which do we do first? Now, once you get used to these, you'll know which to do first. It won't be a problem. But initially, you may think, well, do I subtract 2 or do I divide by 5? And our inclination usually is to do the operation that requires the least work first. Why is that? Because we clean up the equation that way. Now, if we were to divide by 5 first, remember we have to do the same operation on the entire equation. So we would have to divide this term by 5, we would have to divide this term by 5, and we would have to divide this term by 5. And that doesn't seem like it's the simplest operation to do first. What about subtracting? If we subtract 2, we're subtracting 2 from this side and from this side. And this seems like the better first step to do. So let's try to do that. I'll rewrite this equation. 5 times x plus 2 equals 17. So our first step will be to subtract 2 from both sides. We have 5 times x plus 2 minus 2 here on the left, and then we have 17 minus 2 on the right. So on the right, 17 minus 2 is just 15. On the left, we have 5 times x plus 2 minus 2. That's exactly 0, right? So plus 0. And we remain with 5 times x equals 15. Now we can divide by 5, right? So we can write divide by 5, divide by 5. 5x divided by 5 is exactly x, right? We're dividing 5 by itself. 15 divided by 5 is 3, and so we remain with x equals 3. So this is a pretty clear example where it made sense to first subtract the 2. In general, that will be the rule. First, you get all the x's to one side, and you make sure that you don't have a mixture of the variable with some free constants like this 2. Once you do that step, you can go on to divide by the coefficient. Let's look at another example, another simple example. Let's look at the example 3 times x equals 7 plus x. Okay, in this example, this x here is isolated, but unfortunately we have another x here, okay? And in order to divide by 3, we really should first make sure that all our x's are on the same side of the equality. So I'll write this down. Make sure variable on one side only. Okay? So in order to do that, let's try to get rid of the x on this side, on the right. To do that, we have plus x here. What is the inverse of addition? It's subtraction. So we will subtract x from both sides of this equality. So we have 3 times x minus x on the left equals 7 plus x minus x on the right. Okay, let's start with the right. On the right, we have x minus x. So again, these two cancel, right? Because we have positive x minus x. And in both cases, though we don't know what the variable is, we know that it's equal to itself. So we can cancel these two x's, and on the right here, we have the number 7. What about the left? Now, on the left, the answer is 2x, because we have 3 x's here, and then we're taking away 1 x. Remember, we don't know what x is. It's a variable. It can be any number. But what we do know is that we have 3 of them, and then we have minus 1 of them. Imagine that x was an apple. If we had 3 apples and we took away 1 apple, we would do 3 minus 1. And that's basically what we're doing here. So we have 3x minus 1x, right? I can write that out again so that it's clear. 3 minus 1 is just 2. So we're left with 2 x's equals 7. Now we can divide by 2, right? We'll divide both sides by 2 because we want to isolate x. And we remain with 2 times x divided by 2 equals 7 divided by 2. Now again, because we're multiplying 2 times x, and then we're dividing by 2, and these are inverse operations, we can change the order so that we get 2 divided by 2 times x equals, and 7 divided by 2 is 3.5, and you can check that on your own, but the 2 divided by 2 cancels because a number divided by itself is just 1, and we get x equals 3.5. And again, if you insert this into our original equation, you will see that it is correct. So to check, you always take the result and substitute for the variable in the equality. So let's do 1 or 2 more examples before we go on to a word problem. Let's take another one. Let's do 3 plus 2 times x equals x. Okay, this is slightly different. What would be our first step here? Well, we have 3 here, we could subtract 3, right, if we want to isolate the 2x here. But if we did that, we would still have an x remaining on that side. So that might not be the smartest. If we divide by 2, we have to divide this side by 2 as well, and this 3 by 2. So again, doesn't look like the right thing. What if we try to move this x to this side, so that we have our x's on the left-hand side of the equation? That might be a smart move. Okay, so let's do that. I'll write the equation here again. 3 plus 2 times x equals x. So let's subtract x from both sides. On the left-hand side, we have 3 plus 2 times x minus x equals x minus x. Okay, what is x minus x? Well, despite the fact that we don't know what x is, if we have one and we're subtracting the other, we remain with none. So that will be 0, right? On the other hand, on the left-hand side, we have 3, and we have 2x, or 2 times x, minus 1x. So again, regardless of what x is, let's imagine it's an apple. We have 2 apples, and then we take away 1 apple. We remain with 1 apple, right? Plus x, and that equals 0. Okay, so that was the first step. Our second step now will be to really isolate x by subtracting 3 from both sides. Okay, so we have 3 plus x minus 3 equals 0 minus 3, right? Although it's 0, we still have to use the operation on both sides of the equality. So now on the left, we have 3 plus x minus 3, right? And minus 3 cancels 3 here. Even though the x is in between them, they will cancel. So we have x equals, and 0 minus 3 is negative 3. So our result is x equals negative 3. Now, if we had started with one of the other steps, we actually would have had to do 3 steps in order to solve. If we had started by dividing by 2, we would have had to divide this side, and then we would have had to move the x anyway to this side. So it's good that we waited with that. Let's do another example. Maybe an example where we actually do divide first. So let's look at this example. We have 5 times, in parentheses, x plus 3 equals 10. Okay, what do we do with this? If we were to do minus 3, if we will subtract 3 from both sides, we have to open these parentheses with the multiplication here, a little bit of a complication. What if we just start by dividing by 5? This time it really makes sense, right? Let's divide by 5 and see what happens. Okay, so we have 5 times x plus 3 divided by 5 equals 10 divided by 5. So now on the left we have our 5. We have x plus 3, right, multiplying, and then we have divide by 5. So we can move things around a little bit, right? We have the commutative law. So we have 5 divided by 5. I'm moving this one over there, times x plus 3 equals 10 divided by 5, which is exactly 2. Now, 5 divided by 5 is 1. We can also write this as 5/5, right? Which is also 1. It's a whole. So we have 1 times x plus 3 equals 2. But because we have 1 here, right, on this side, we can just open the parentheses. It's just 1 times this. So the 1 cancels, and we have x plus 3 equals 2. Now, let's subtract the 3 from both sides, and we get x plus 3 minus 3 equals 2 minus 3. The 3 and the minus 3 cancel, and we'll remain with x equals 2 minus 3, which is negative 1. And again, we can substitute our result in the original equation in order to check and make sure that what we did was correct. Okay, so I think we are ready now for a word problem. And let's copy a word problem into here. Let's start with this one. Okay, what do we have here? We have Tom, who has 20 candy bars. Okay, now one of the important things to do when we have a word problem is to find all the numbers, all the information that we do have, underline it or highlight it in some way so that we know what to look for. So let's look at this. We have Tom has 20 candy bars. Okay, so that's our first piece of information, 20 candy bars. He is saving 5 for himself and will hand out the rest equally among his friends. If each friend gets 3 bars, how many friends does Tom have? Okay, so our first order is to find out what our variable is, right? To figure out what we're being asked to find. So the question is, how many friends does Tom have, right? So in order to figure that out, we will set the variable x as number of friends. Okay, so x is the number of friends. Let's now try to write out this problem as a story as a math expression. So we'll convert the story into math. So Tom has 20 candy bars. Let's write that out. So we have 20 candy bars. Now we know he's going to save some for himself and we'll give some to his friends. But the total is 20. So let's write that our total 20 equals to what Tom eats, right? Plus what he gives to his friends. Okay, not the number of friends, but the number of bars, right? Bars and bars. Okay, so 20 equals, now Tom is going to eat 5 bars, right? He's saving 5 for himself. And he will give 3 to each of his friends. So if he has X friends, he will give each one of them 3. So overall, he's going to give away X times 3, right? Because each friend will get 3 bars. So just by repeating this question and translating it into math, we now have an equation that we can solve. Let's go ahead and solve it. So 20 equals 5 plus x times 3. Our first step will probably be to get rid of 5, right? When I say get rid of, I mean to get it away from this right-hand side of the equation. To do that, we have plus 5, so our inverse operation is to take away 5, right? To subtract. So we have 20 minus 5 equals 5 plus x times 3 minus 5. And again, on the left-hand side, the two numbers, the 5s here, cancel because we took the inverse operator. Now, on the left-hand side, we have 15. 20 minus 5 is just 15, equals x times 3. Now let's divide both sides by 3, and I'm going to use shorthand. Instead of writing divide by 3, I'm going to use our fraction way of writing. So instead of writing a divide by 3, I write a third, but I neglect to write the 1 because in the denominator we already have these numbers. What is 15 thirds? It's exactly equal to 15 divided by 3. It's 5, right? And that equals x times 3 divided by 3. 3 and 3 cancel, right? They could subtract, and we get x equals 5. So Tom has 5 friends. Okay, and we can check this by inserting it back into our main equation. So that was our first video on multi-step, and we started with two-step solutions for these equations, and I will upload another video with some more word problems so that you get a lot of experience both working with the equations, solving them, and actually building them from the word problems. Let's just recap a few things to remind you of how we solve these things. We look at the inverse operations, right? We look at our equation and we find the elements that we would like to change, and we look at inverse operation in order to isolate. So we're always looking to isolate the variable. Okay, and in terms of the order of operations, you have to be a little smart, but usually what works is if there are no parentheses, usually you're going to want to do addition or subtraction first, and then multiplication or division. If there are parentheses, you may want to start with division or multiplication if there is a coefficient in front of the of the parentheses. But it all depends on how complicated the equation is, and I promise to go through many examples which will really facilitate your next problems. So thanks for joining me again. If you're new to the channel, please subscribe, like. If you have any specific questions about these equations, two-step, one-step, and multi-step solutions, I'll be happy to look at the problems and maybe include them in a future video. Till then, goodbye.